Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSO IIT Kharagpur who is taking this course for you. And today we are in week 6 and we are discussing about marketing mix models and advertising models. So, in the last video we have discussed about how the various items of marketing mix actually interplay with each other. But in this particular video, there we have taken a linear model, simple linear model, and we tried to find out that how the effects are different. But in this particular video, we will try to do a little bit more. We will try to bring in a little bit of complexity, non-linearity in the model and the effects of the past behavior also. So, if you see the data set that we have in week 6 season 2, I think, the data set looks like this. And if I just zoom it up. So, there are quarterly data, quarter of the year, quarter number and the advertisement spent, price that you have done, and this is the actual sales that had happened. So, I will first don't look at the other things, we will discuss about that. First focus on column number C, D, E, G and I. So, quarter of the year, this is varies from 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 and so on. And the next come is quarter number. So, there is a so quarter number means how much data point I have. So, that serial number is given here, the advertisements expenditure, the price that I have and the actual sales values that I have. So, these are the 5 data points that I have currently. Now, I have to decide that what kind of advertisements. So, how, if you remember that the first thing that we decide is how the sales is dependent on the price and the advertisement that we have done. Now, advertisement is oftentimes is assumed to be like this. So, for example, we do not keep on giving advertisements. If this is time period and this is the effect of an ad, and let us say you give advertisement here, here, here and here, the corresponding sales or the effect of the advertisement will first shoot up, and then in this period when you have not given any advertisement, people still remember about you, but slowly that memory comes down. So, memory decays, the decay of memory happens. So, it happens like this, and then again you give some ad, again it goes up, again it happens like this, and again it goes up and again it happens like this and so on. Now, how the decay will happen, whether it is a linear decay or non-linear decay or curve related decay is something that is still a area of research, but these kind of things happen. So, all I am trying to say is that at this point the effect of the ad is dependent on how much ad you have given here and how much decay has happened. So, based on that assumption, there are lots of equations that has been created. So, one of them is like this, where there is something called ad effect. So, if you carefully see the formulas here, it has been written here that ad stock, there is something called ad stock. So, I am saying that the ad effect gets in my memory as a stock. It's like it behaves like a inventory. Whatever there in the inventory models that we do the similar thing here. The ad stock is lambda into the previous stock. So, whatever previous stock was there in the last time period, that will decay a little bit. So, last time period probably let us say the measurement was like this. At the last time period the measurement was like this. Lambda into this comes here. So, this particular measurement is basically, if this is A, the second one is lambda into A. The next time period it will be lambda is basically between 0 and 1. So, that is lambda into previous stock plus the ad spend. Now, if you give certain ad plus the current ad. So, if you give certain ad at this point, it will shoot up. So, it will decay. If you give certain ad here, it will again shoot up. So, that is something this particular function is writing about. So, which is ad stock is equal to lambda plus previous stock plus current ad. So, this is something that we are trying to do here. And then the sales has different components in it. So, I will explain one by one the various components of the sales. So, the sales has different component in it. The first component of the sales is, let us say, the price elasticity. So, I am keeping everything else constant. So, if everything else remains constant in this equation, so sales is equal to price to the power minus elasticity. So, why that is coming up? What is elasticity? Elasticity is basically delta d by d minus, where d is the demand and delta p by p, that is elasticity. There is a formula. So, if you remember that, that is the formula of elasticity. So, then I can write delta p by p is equal to, or is equal to minus delta d by d. Can I write this? Or can I write delta d by d is equal to minus E delta p by p? Fair enough. Now, can I then write this, that del d by d is equal to minus E del p by p? I can write this. So, if I write this and then if I do try to do a integration in the both sides, I will get basically log of d is equal to some constant minus E into log of p. Am I fair enough? So, log of d is equal to some constant into log of minus p. I assume that constant to be 0. So, then d is equal to basically ln d is equal to c minus ln p to the power minus e. This is the formula. So, a log b can be written as log of b to the power a. So, that particular formula I have used here. Fair enough. So, then d is basically equal to, so if c is equal to 0, then e to the power ln p to the power minus e, basically p to the power minus e. So, that is why all I am getting is demand is some constant into price to the power minus elasticity. Now, that part is clear. So, the price effect on demand is basically price to the power minus elasticity, assuming that it is your price. If it is somebody else's price, if it is a customer's competitor's price, which where the price increases, your demand goes up, competitor's price increases, your demand goes up, then that would have been price competition into minus plus elasticity of competition, because this is called cross elasticity, the elasticity of somebody else's on your demand, which is a positive effect, but I am not taking into account that part right now. So, I will probably delete that part. So, this is what I have. So, then price it to the minus elasticity, and then the demand will have a seasonal component and a trend component. The seasonal component is basically a seasonal component, seasonal index. This will be multiplied by some particular constant, and then there will be some trend component. Now, in this particular function, the trend has been defined as a multiplicative trend. So, trend to the power quarter number. You can also write trend into quarter number, no issues. So, trend, let us say, into quarter number. Okay. And then there will be a constant in at the front. Now, the only part that is left is how the advertisement will affect. Now, advertise will not affect on price, advertisement will not affect on seasonal index, advertisement will affect on the trend. So, it will either, trend is what, whether it is going up or going down, that going up or going down, it will push further up or further down, something like that is what the advertisement will do. So, that is some beta parameter into the ad stock, that is what will come here. So, this beta parameter into ad stock we have writing is as ad effect into ad stock. So, I will change this part as quarter number into this thing. You can do multiplication or So, this is something is my overall sales. Now, what I do not know, what is my previous stock, I do not know what is my lambda, I do not know this constant, I do not know the trend component, the add effect component, the elasticity, the seasonal index, all of these things are not known and I have to estimate them. So, to start with, I thought that each of them is 1, everything, and initial stock is 10. So, how much is the add stock then? The add stock is here initial stock plus initial stock into lambda plus current add, and this here it is previous add stock into lambda plus current add, and here before I jump the lambda should have been F4. So, this is what my add stock is. Fair enough, add stock looks like this. Then what is the sales forecast? The sales forecast is basically, carefully you see, the sales forecast is this constant into the trend component, I will write something here, into the price to the power minus elasticity component, I will write something here, and into the seasonality component, I will write something here. So, let us write the seasonality component. Seasonality is what? VLOOKUP, what VLOOKUP of this quarter number in this particular table, and 2 comma false, and this L6 and M9 should be in a table form. So, that is what I have created. VLOOKUP C6, C6 means the quarter of year, in which table? L6 to M9. So, this table and then 2 comma false. And what is the price to the power minus elasticity? This is price to the power, and within another bracket here I have to write minus elasticity, minus this elasticity, and elasticity also should be in F4. And then, so you can pause at various point of this particular video and see, and then the quarter number into the trend, quarter number into the trend, and trend should be F4, plus add effect into add stock, and add effect should be F4. So, that is my forecast, and if I just drag it, this is the forecasted sales that I am getting. And what is my average percentage error? This is my forecasted minus actual divided by actual, something like this. Okay, absolute. So, I will take ABS. And mean absolute error is basically average of these values. Average of these values. Why it is coming 0 here? Okay, so M5 should also be in F4. Okay. So, mean absolute error, this is the thing, and this is the guy whom I have to minimize. So, I go to data solver and I try to minimize this particular person. So, I will say that set this my working directory here, set my objective on that cell J4, and then minimize this, and whom will I change? I change all the parameters that I have to estimate. I will change this people, comma, and my initial stock, which I do not have an idea. If I have an idea, I will put that. Otherwise, if I do not have the idea, I will put that there. Now, all of these guys will have certain constraints. For example, let us say the add stock, the initial stock. The initial stock will be greater than 0. and initial stock will be smaller than 100, something like that, because you will see that all the other expenditure is between 0 to 100. So, I am keeping it between 0 to 100, fair enough. And then let us say these values should also be greater than 0. See, the effect of advertisement on sales has to be positive. The elasticity we have assumed to be positive, that is why we take minus elasticity. The trend component can be whatever, I do not know, negative, positive. So, I will not put the trend component in this thing, and then let us say the lambda, or let us say trend also positive, because it is going up a little. If you plot, you will see that the trend is also going up. The lambda is between 0 to 1. So, this is something that is important, we have to check, and this constant terms has to be positive, otherwise your sales will become negative. So, I will put everyone here has to be greater than equal to 0, okay, and let us say everyone has to be smaller than equal to 100, add, and this lambda decay. So, this has to be smaller than equal to 1, add. Anything else? I think that is fine. So, these are some of the constants that I have written, and I will use, let us say, evolutionary method, and I will try to solve it. So, all variables must have upper and lower bound. So, do I not have for every variable upper and lower bound? I have to check. For example, okay, so this has been written as I 1, sorry. So, change this will be not I 1, but H, not H 1 or I 1, okay. H, and then M 1 to M 9 is between 0 to 1, and M 4 is more than 1. Now, I have to try to solve. So, it is solving, and it has already reduced to 0.215, and it will take some time, probably. I will wait for 1 minute to see what happens, and then I will press an escape. So, what it is doing is, it is trying to change all these values and trying to reduce this MAP as lower as possible. When I get that, what I get is the function of sales, where some level of non-linearity has been taken into account in my picture, and okay, so it is stuck at 212. So, I will just press an escape here, and I will stop, and I will say that okay. So, keep my solver solution, and this is the values that I am getting. So, where it is saying that I could have done a little bit more probably. So, it is saying that these are the add effects. You will see that for every this thing, it is going up by 51 for every increase at stock, and the elasticity is like this, and the trend is like this, and so on. The values for all the lambda value is coming up to be 1. Lambda value coming up to be 1 means absolutely full add effect in the next, which should not be the case. So, if you had run the solver some more time, would have got a better lambda value. There is no decay at all. So, this is something that is being shown, which might not be the case properly. So, this is something that we have done till now. Now, another addition of this thing is, see, add stock here we are writing lambda into previous stock plus current add. Now, oftentimes the researchers suggest that the effect of add is not linear, that your add expenditure goes up and your add effect, this guy will have this kind of a relationship, which is it increasing, but the marginal increase drops. That means, it will look like I would say look like a S curve or something like that. So, what it will finally actually saturate at some level. So, to bring in that part of the story, where the effect of ad spend on the ad effect is actually coming down as the ad spend going up, the marginal effect is coming down. To take that, we are introducing a logistic function. So, here if you see, this part is actually a logistic function. So, where 1 by 1 plus e to the power minus alpha into ad spend, and we are estimating one more parameter. I can just put one more parameter alpha, and then I can estimate it, and I can try to solve this thing. So, this is something that I will not do. This is something that you should try to do on your own when you try to solve with this particular sheet. So, only thing is, you have to put another this thing called alpha, create the functions based on that, and then optimize alpha as well. Remember, alpha has to be also positive, because otherwise add effect will be going up like this rather than coming down slowly. So, that is something that is. Now, once I have these results, what do I do? Let us say it is a next time period. In the next time period, this one is 1, this one is 25, and let us say I do a expenditure of 32. Then how much is my ad stock? My ad stock is something like this, and let us say the price is let us say around 41, and then this is my expected forecasted sales in the next time period. Now, I might want to know that at what level of price and what level of ad expenditure this particular value, which is a forecasted sales, maximizes, or if with this forecasted sales we can do the forecasted revenue also, as we have forecasted profit also, as we have done for video 1 week 1 week 6 season 1's video. We can do that kind of calculation also. If my job is only to sales maximization, I have to find out that now if I change this, if I try to optimize this based on the formula, I got this thing. If I change 32 to 30, this value changes. If I change 41 to 45, this value changes. So, what combination of these two will give me the best result? So, all I am trying to do here in comparison to the previous Excel previous video or previous session is that we have created a functional formula which is a little bit difficult to estimate, which is bigger than the previous one, where here the non-linearity components were also included in the model, and based on that we are trying to predict how much will be the this thing. And lambda is right now I am getting 1. Actually, in real life situation, lambda is something smaller than that. You can actually estimate lambda outside your data set also, and you can put that value, and then you will be finding out the decay effect of the advertisement. If you have run this particular thing for some more time, probably you have also seen the decay effect, and that is how the advertisement and sales promotion works. Now, till this video, we are still discussing advertisement and sales that means advertisement and pricing as only one single component. So, there is only one type of ad and there is only one type of price, but we have not considered multiple types of price promotions that you can give and multiple pricing schemes that you can give in combination with multiple types of ads you give. This is the collective ad expenditure, but the effect of ad expenditure might be different for TV. The decay will be different for TV, different from radio, different for other people, which is still not being seen in this particular video at a greater depth. So, in the next videos where we will discuss about marketing mix and etc., we will go in greater depth about how various types of ads in various channels will actually affect. And we will also bring in the other components of marketing mix. As I told that marketing mix has the product component also and the place component also. So, you have to decide that okay, if you have a marketing budget, how much money. Now, this marketing budget sometimes comes into account with the supply chain budget as well, but still if I think overall as an organization, they can put money on the supply chain side, on the margin and etc. side also. So, where sales and your branding managers, these are the two people where in most of the organization they are competing with each other. The sales guy say that the marketing guy gives me or branding guy gives me unrealistic assumptions, or branding guy promises such things which cannot be delivered, and the branding guys often tell that these sales people are not performing well, they are not actually pushing themselves and etc. etc. So, these two people who are sales guy who actually talks about, who are in the field, who talks with the retail stores, who gives the margin, and then there are certain supply chain managers also who gives the margin to the, who give certain rents to the travelers, transporters and etc. These are all place related costs, place related investments. Now, how those investments interplay with the advertisement expenditure in multiple channels that you are doing, and how all of these things also are related with this R&D expenditure or product development expenditure that we are doing, or product management expenditure that we are doing. This is something we are slowly going to a little bit more complex models. Here we have brought in a little bit of non-linearity, but further more complexity can be brought in our data set. So, we will do that all of these things in the next videos in this week 6 only. Thank you for being with me. I will meet you in the next video.